Hello. Mm, Good morning, everyone. Is anybody in the chat? You guys hear me? And everybody hear me. I'm just gonna wait a few minutes. It shows here that everything's okay, so should be okay. Okay, I'm thinking probably waiting, I don't know, maybe like 11, uh, 07, 010, something like that to start. Just to allow people to log on. Does anybody know how can I see the YouTube chat? Because it seems like I can't see it. Let me see. There's a chat here, but it's a group chat. Wait, maybe here. Okay, I see a YouTube chat. All right, so there's also another chat, talk.io. I'm posting the link. I'll be trying to keep an eye on both of those, like the YouTube chat and the talk.io chat, for any questions or anything like that. Okay, I think we're good to get started. So, good morning. My name is José Alvarado Coronel, and the introduction to working with Django and Docker. Uh, don't feel too overwhelmed about it. It's going to be lightweight. If you guys have any more like in-depth questions, you feel free to also email me or message me. Okay, so first of all, wait, sorry. Okay, now I just lost my presentation. Ah, there you go. Yeah. So first of all, let's talk about what Docker is. Docker is a technology which is actually built on top of containers in Linux. So containers are an idea that actually is actually brought to us by the Linux kernel. And these containers, basically what they are is just a way to isolate different spaces in an operating system. Now, the important thing here to know, I mean, we can actually dive into these for I don't know, for a few days, but the important here to know is that containers allow us to isolate different parts of the operating system, and they are implemented or they are offered only by the Linux kernel. So for instance, if we take a look here at the image, we can see a difference or a comparison between containers and virtual machines. Containers are not virtual machines, are something totally different, because virtual machines actually need to virtualize hardware and virtualize other type of resources that a machine needs. But a container actually, it's not virtualizing anything. It's a very lightweight layer on top of your already existing operating system. So on the left, we have what usually will be a virtual machine. So for instance, you have your host, and then you have something like hypervisor, which is one type of, uh, uh, of virtualizing technology. There's also other kinds. And then on top of that, you install a guest operating system. So for instance, you could have like, I don't know, maybe you could be running Windows, and then you can create a virtual machine, which is running OS X or maybe Linux or maybe Unix or any other type of operating system. And then on top of that, it's where you work. So that's not what containers are. Containers are actually more a little bit in a lower level. So you have, for instance, here you have your host operating system, which could be, say, like Ubuntu, and then on top of it, you can actually create containers which are shared by that operating system. So, for instance, you cannot create or you cannot use a Windows container if you're running on a Linux machine. You can do the other way around, but we're going to talk about it. It's actually not on that machine. Here in this example, we're talking about Docker specifically, right? Because containers itself, those were not created by Docker, but Docker added a lot of different things, or a lot of different good things on top of that technology to make it easier to work with, and also to make it easier to copy, easier to replicate on everything that we like about containers. So let's move on. As we can see here, the way that Docker works, or well, containers also, it's that first we have an image. So at the bottom of this image, which is, well, I mean, it's kind of weird, but at the bottom of this image, we have an image which is actually what we need to create first before creating containers. An image is basically just well, a layer actually that tells that tells the container, oh, it's basically just kind of like the installation of of what a container is gonna do. So think about it just like the very variables of what a container is going to be. Now, the interesting thing about this is that, as we can see here in this figure, is that multiple containers can share one same image. And that's one of the beauties of it, because, for instance, in an image, we would usually say, okay, these are going to be my requirements. This is all the users that I want to work with in groups, and maybe I don't know, these are the files that I'm also going to use. So those are always going to be the same on the image. And then from that image, we can create multiple containers, which those containers are the actual ones that run. So an image is never going to run, or is never going to be executed in our application. A container is the one who runs the application. So this is one of the good things about this entire technology, because that way we can share different commonalities, different commonalities across multiple containers. So we'll still, I mean, dive a little bit more about on this as we go along. Um, Now, the other interesting part about containers is that they can also share different resources. In this image here, or in this figure, we can see that two containers are actually sharing one specific volume. This is very important because sometimes we want to share data between containers. Think about it in this way. For instance, maybe here container one will be our I don't know, HTTP server like Nginx, and then container two will be like our Django application, right? So now Django will collect static files, which are going to be served by Nginx. So those, wherever those static files are going to be written into, that's where we can share data between these two containers. So we can we can actually write different type of files and data onto the host machine, which is the one that we have on the left, and then have the other container read it. So we as we can see, like the good thing about this is that then we are sharing a lot of different things here, from images, from Docker images here, where we're talking about this image, right? I mean, this square at the bottom of this image. Um, we're sharing all the different setup that we need to have on an environment, how to set up our environment, and then on this figure we can see how can we share data. So if we're already sharing our setup, and if we're already sharing different type of data that we need in an application, then what we're left with is just a very lightweight layer, which is what the container is actually is, which is just basically running the service. For instance, just running the Nginx executable, or maybe running just Django run server, or maybe running an application server like you with your Unicorn. So that's a good thing, because then for containers are created from these Docker images in this example, and they grab data from the host machine. So the actual layer of what a container is very lightweight. Okay, let's move on with, well, now after having all these different containers, what we can do is then we can start actually running different applications. So if you guys want, you can actually follow up on this class here at the bottom. I put a repository, and there's a lot of different examples there, which I'm gonna go through. And here also it says repository, and it has multiple branches. So for each one of these branches, there's like a different section here in this class. So let's start with what we went through. First, like what a container is and all that. Let me just change here. Change the. Uh, I'm gonna. I'm, I'm gonna stop share my screen to. Oh, it's my terminal. Yeah. Let me see if that worked. Looks like that worked. Okay. So here I am in this repository, which is the one that I was talking about. And you can follow along also through the README steps. So first, I'm actually, well, we're actually just doing something very, very, very simple. So first, we can go to section 1. And here on section 1, we can see that, where's my, uh, yeah, uh, yeah, okay, sorry about that. So here, what we're gonna focus on is this Docker file. So first, in order to create a Docker image, what we need is a Docker file. So if we open this Docker file, we can see that it's actually something very simple. And this is because in Docker, you can actually create images based of other images. So in this case, just for as a very simple example, what we're gonna do is that we're gonna create an image, an Nginx image. And the only thing that this image is gonna do is just run Nginx, which is an HTML server, and it's gonna serve some static content. This is just so we can see like how easy it is to do it. So for instance, here what we're doing is that we're telling Docker to create an image based of this other one, which is Nginx Alpine. And it's called Nginx Alpine because Alpine is a type of Linux distribution that is very lightweight. So a lot of people use it to create their own containers. You don't necessarily have to use Alpine to create container images. I mean, Docker images. You can use other versions, like for instance, CentOS or Ubuntu, or I don't know how many others are out there, but there's a lot. So whatever is easier for you. I will recommend always to try and create Docker images based on the same operating system that your server is running on, just in case that you need something that's specific to that operating system. Like for instance, there's a lot of people that use CentOS in production, and then if you run everything on Ubuntu containers, then you're kind of missing a lot of the security features that CentOS give you, like SE limits and stuff like that. But that's really just a recommendation. You don't really have to do it. You can just use whatever other Linux distribution for your Docker images. Anyhow, so we're telling Docker to start a Docker image from Nginx Alpine. And then what we're doing here is that we're copying actually one file, or well, this directory, the HTML directory, onto our image. And this is going to happen when the image is created. So that's going to stay there. It's just going to be like kind of frozen in time. So the way to use these Docker files is to build an image. It's actually running Docker build, and then usually it's a very good idea to tag it, and that's you do that using like this dash t, and then for instance we can call it like class nginx, and then just like a version one for like or section one. Um, this format here, there's really no like a specific format that you need to tag your images. But this is very useful because, for instance, you can put like here first the name of the project, then slash, and then what is the image actually running or what is it based off, and then colon, and this is just kind of like the version of it. It could be like semantic versioning or any other type of versioning, really. And then here you really just tell Docker to use whatever current directory you are in order to build this image. Let's see if this works. Hopefully it's gonna work. Let me see, well, these builds, if there's any type of questions. No? All right, cool. Okay, so now, as we can see here, Docker is building this image, and at the end of it, it tells us like, okay, there's this new Docker image, and the tag of it is this one. Now, each one of these steps is each one of the different commands that we put here on our Docker file, right? Um, this is very important to see or to take into consideration, because whenever Docker actually builds an image, what it does is that it creates different layers from each one of these different commands that we give it. There's an entire specification on all the different commands that you can use in a Docker file. You can take a look at it on the Docker documentation. And I'll put some links on the repository too, just in case in case everyone needs to like a quick link to that. Um, but the important things about these different layers is that they are cached. So, for instance, if I build this image again, since nothing has changed, actually, it tells me right here that is using a cache. It's using a cache, right? I mean, for instance, from in this copy. Uh, but if I go ahead and I change this command, for instance, maybe I want to copy this file into, I don't know, instead of user share nginx into something else like I'll just do like something else. Then we'll see that this layer or this step here is not going to be cached anymore. You see? This is very important whenever we're like building a lot of different images or building images that are a little bit heavier than this. I'm just going to change it back to so it will work. So this is something good to take into consideration. We'll show better examples in that just in a little bit. Okay, so now we have our image. We can actually check every image that we have on our host by using Docker images. So right now I have a bunch of different images, but let's just focus on wait, where is it? Yeah, let me take. I can grab these actually just to get. So there you go. This is the one that we created. Um, and then once we create the image, as we were saying, like this is not the we're not gonna use an image in order to run anything, right? An image is just like whatever the environment is gonna be for a specific container. So we first have to create an image and then we run a container. So the way to run a container in this example, actually, I have put here uh, very easy. Well, just like an example of how we can run it. And we will go through it. First, we tell Docker to run something, then we give it a name. We give a name, and that's the name that that container is going to have. Then here, this dash p, this is actually the ports that a container is going to have open to. So the one on the left is the one for the host machine, which is like this laptop, and then the one on the right is the one the port inside of the container. And this is because this image, what it's going to do, or this container is what it's going to run Nginx on port 80. So what we want is that we want to map it onto our port 8080. And then we tell it what is the name of the image that we want to use. So we fire that, and then what we can see is that if we go to any browser to localhost 8080, oh, wait, you guys are not going to be able to see it. Let me, let me see. So, sorry, let me share. How can I share the entire? Oh, your entire screen. There you go. Okay. Yeah. So for instance, here, if I go to localhost 8080, this is what we see here. And we can take a look at what is the, let me just go to where this code is. What we just copied, it's what we have here. And basically it's just this header saying we did it. So as we can see now, that's how easy it is to run just Nginx and host of static content with Docker. It just took us like, I don't know, 10 minutes or something like that. That is pretty it. Now, let's see if there's any questions. No? Okay, cool. Right. Now, we have just created an image and we have just run that container. Let's stop this. The way to stop it right now, if you see, we were just running this Nginx container, and then you can hit Control C, and then you're gonna stop that container. Now the interesting part here is that, for instance, if you try to run it again, you're gonna get an error, and it's gonna tell you the container name my site is already in use by another container. And the thing is that every time you do Docker run, Docker is gonna try to create a new container, but you don't want that. Or well, I mean, really, what you want is just to remove the other container, because every container that you create, it needs to be ephemeral in a way that everything that you set up there, you need to think about it in a way that eventually container is going to be deleted. Uh, so if we do Docker PS, this is how we can see, sorry, PS-A, this is how we can see all the different containers that we have. For instance, here it was telling us a container name my site is already used by another container which starts with AF33, which is this one right here. So if we want to run another container with the same name, we can just remove this one using Docker rm and using this container ID. And then we can run it again. There you go. Let me show it to you. There. Still running. Hit Control C again, and we close it. Now there's another better way to run it, which is adding --rm. What this is going to do is that every time, sorry, let me just, I need to do it again. If we use rm, --rm, every time that we close it, that container is going to get deleted. So we try and take a look at all the containers that we have. It's not there. It doesn't stay there that way. So whenever you use Docker run, it's always good to use dash dash. All right. Let's move on to section 1.1 of these. Okay. So now what we're gonna do here is that we're gonna add something else to this, and this is basically we're gonna add another configuration onto Nginx. Let me remove spelling, yeah, so we can all see it. You can see this last line here. What we're copying, what we're doing is that we're copying this file onto Nginx's configuration here, which is inside the container. Now, if we take a look at that, uh, this file, the only thing that we're doing is really just adding this location. So we're telling it, okay, the HTML is here, and these are your index files that you're going to serve in case that there's nothing else. And then also we're adding this other route here on Nginx, which is images. And this is just so we can see how can we mount a volume onto a container. And by volume, that's what I meant when we're talking about like sharing data between containers. So right now we only have one container, which is this Nginx container. But what we're going to do is that we're going to serve an image which is not inside the container, but in a host machine. Let me see. Yeah. Also, I put a handy command here on README so you guys can follow along. And here, what we're doing here is that we're telling Docker to run a container, right? Dash dash rm. We're gonna name it my site again. We're gonna open the port, or we wanna map the port 8080 on our machine to the container's 80 port, and then this dash v, this is the folder. So we're telling it mount this folder, which is in my local, in my host machine, mounted into this path on the container. Sorry, which is srv. Let's see. Let me. This. Right. Okay, we have an error in our configuration. Wait. Sorry about that. Oh, yeah, I remember. Sorry. Okay, so before running it, sorry about that, we need to build the image again because we just changed the Docker file. So we need to build it again. That way, we're gonna have an image with these different updates. Then we can run it using that command, and it's gonna be serving it. Okay. We'll make sure this is no, this always happens with live coding. Let me see. So we're moving these things here. Okay. Pushing these. It's saying that index. Is it? Wait. 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 Into just um. Oh, I remember. I'm not using the correct image here in my commands. I was trying to use an older image that I created when I was testing this, and it didn't have the correct parameters there. So now if we go back to our site, we can see that now we're serving this image. And it will take a look at where that image comes from. It comes from /images, and it's just Django.jpg. So now what we're doing is that Nginx is easily serving any type of files that we have locally. Okay, this is just like an example on how to do it. Now, the other thing, this is just kind of like your basic stuff about how to build an image and how to run a container and how to run a service in a container. To let me remember if it's section 1.1, 1.2, yes, 1.2, which is Docker Compose. Basically, what Docker Compose is it's a way to automate all these different container or well, yeah, creating containers and running containers. So the way that we do it is that if we go here, you can move on to this branch section 1.2. And then here you'll see that there's a Docker compose.yaml file. And this is basically the way that Docker Compose works. It has a configuration file, which is called Docker compose.yaml, docker-compose.yaml, and it's very, very simple to set up. So for instance, here, what we're going to do is that we're going to set up exactly what we had, what we did on the command line with Docker run and Docker build and all that, but just in a nice small configuration file. So this is the good part about Docker Compose because it gives you a way to simply configure these different type of services that you need. And that way you don't have to keep remembering like different commands or anything like that. So that way there's just one file and you can build everything from there. So for instance, here, what we're doing is that we're creating a service. So first, we're always gonna put which type of version it is. Right now, the latest version is, I think it's 3.3, but it's okay to just use 3. Um, then we have to define all of our services. So for instance, here we're defining our Nginx service, and this is really just an anything. It could be anything. Here it could be like a web server, or it could be literally like anything else. I usually tend to name it I tend to name my services on what the actual service is. So for instance, here is going to be Nginx. Then we specify how is this going to get built if we want to. This is optional, but it's always good if a service needs to be built. It's always good to specify it here. And by build, I mean that we're not only pulling an image from somewhere else. So for instance, here on our Docker file, and the first line what it's doing is pulling this image from somewhere else, which is from Docker Hub. So Docker has a hub where they host a lot of different images. So here what we're doing is that we're telling Docker Compose, if there's not an image yet for this, you need to use this Docker file to create it. And then we are telling it what's going to be the name of the image that it's going to use. So for instance, here, let's just put like version 1.2, just for the sake of it, just so we can see how we're creating like different type of images. Then here we specify the ports that we're opening and then the volumes. So it's pretty much the same thing that we were doing in the command line, but it's just configured here in this YAML file. Which this is also a good thing to keep in mind that everything that you do in in a Docker Compose file, you can do it on the command line for a container, and vice versa too. All right. So here, if we do the way to use Docker Compose is to do Docker Compose and then up and enter, and we'll see how it's building the Nginx image. It's building it here, and it's saying like first it's grabbing this, it's getting this image from Nginx Alpine, then it's copying this folder into here, and then it's copying the default path into here. Everything has been successful. It has tagged the image that it just created, and then it tells you it's creating the container so that it runs, it creates the image and then it runs the container, and then it attaches your result onto the container. That way we can see whatever output the service has. So now, since it's running on in the same order on that, we can see that if we just restart this, it's still working. So it's pretty much the same thing that we were doing, except that now we have it in a nice Docker Compose file. Now, if you notice, we didn't really specify in our command here what was the Docker Compose, the configuration file that we were going to use. And that's because Docker Compose by default uses the file named Docker Compose.yaml. It's always going to search for you exactly where you're running that command. Okay, let's see if there's any questions or anything like that. Everything seems all right. Wait. Oh, that looks cool. Ah, all right. So now let's move on to first my presentation. Yeah. Okay. So we went up to what Docker Compose is to. Now let's take a look at just basically how a web application or the way that we're going to set up a web application. And right now, first we're going to do something very simple, which is running just Jekyll. Jekyll is it's a software that allows you to run static files. I mean, static sites. You can create a blog or something like that just with a bunch of different static sites. I mean, different static files. So here, this is basically like the different layers that we're going to use. And first, we have the user, which is going to go and talk to Nginx, which is an HTTP server, which was the one that we're running. And then Nginx is going to reroute that request onto Jekyll. Now, so let's see. I think let's see. Um, yeah. Just fix it here because here it should be section 1.3. Here's section 1.4. Very good. So now here there's been a couple of different changes. Now if we open our Docker Compose, we're gonna see that it's a little bit different from what we had right now, from what we had before. So the first thing to notice is that now we have this links section, our Nginx service. Now this link section, what it does is that it links it to any other type of service, right? So for instance, here we're talking about like it's gonna link it to the other service, which is called log. So we're always gonna use the name of it. This is because Docker itself, when you run multiple containers, Docker also creates like an internal network of it. So if you don't link it, then one container is not necessarily gonna be able to see another container. Um, so this is the way to work with multiple containers that they're gonna talk with each other. Well, this is one way. There's multiple ways, but this is the simplest way. Then for this one, what we're gonna do is that we're not gonna create an image ourselves. We're just gonna pull this Jekyll image, which is already hosted on the Docker Hub. But what we're gonna do is that we're gonna tell it, okay, uh, you're gonna mount our static site, which is in this folder, and you're gonna mount it to SRV Jekyll. And then these ports are the ones that are going to be linked to the container or open onto our local host. This is just so we can test like Jekyll itself. Then here we're specifying what's going to be the command that is going to run, that Docker Compose is going to run whenever it's going to run this container. And we have to specify it here because this specific image actually specifies different commands that can be used with this. So for instance, if we go back to our Docker file, since we are creating it from this image is already specifying a command that's always going to happen. So whenever you create a container from this image, it's always going to run that command, unless you override it. For instance, with Docker Compose by using this, and as we were saying, everything we can do Docker Compose, we can also do just with regular like Docker command. Then you can also do that by doing Docker run, and then you can do like a name to a container, use some image, and then whatever command you actually want to to run. So, for instance, here. Um, There's actually a sample of it. Uh, yeah. So for instance, here we can use Docker Compose to run a Jekyll command, which is run. We use Docker Compose run, and then when we're doing that, Docker Compose is gonna take a look at our compose file, this one. So the way to specify what do we want to run is the name of the service. So for instance, here we can do Docker Compose run blog Jekyll, and this is going to create a new a new site, which we've already created, but it's just so everybody can see how you can run specific commands using the containers that you already have. Well, that run, let's see if there's anything here. Oh, okay, let's see. There's a question from. Uh, It says I'm on a Mac and I install Docker. The Docker will be that succeeded. But when I do the original Docker run command from when you were in section 1, I get an error that it can't find it. So from me. Did I require run Docker run name my site? Yeah. Yes, sir. Yeah. You have to do the image first. So somebody's having an issue that they were doing Docker run and then using the image that we created here. But first you have to build that image. So in order to do that, you have to do Docker build dash t plus nginx v1 dot uh, without, yeah. So first here, Jacob is telling us that it's error now because we already have our static site there. But this is just so everybody can see that we can run a command by using Docker Compose too. Uh, just to jump into one of the questions that we saw on the chat, somebody was trying to run this. Oh, run this, but we first need to make sure that this image has been created. And in order to create it is using this Docker file here. So we do it by using docker build dash t and then the name of the image that we wanted to put nginx v1 and then dots. And that dot is so we can tell Docker that to use a Docker file that is going to be on that same folder. Okay, so um, okay, so now we've shown how we can run a command just with Docker Compose, even though this is not the same command that's in our compose file, which is jQuery serve. That's always good whenever we need to do like a what-off command. Like for instance, in Django, usually the way that I use it is whenever I need to run like collect static or something like that. So let's use our nicely configured Docker Compose in order to run our Jekyll sites. And the only thing that we need to do now that everything is configured here is Docker Compose up. And then we'll see like, okay, this is what's going on. Here, Jekyll is going to automatically start installing different gens and different things that Jekyll does. So we can leave it running there. I'm gonna take a look, see if there's any questions. Cool. All right. So now our site is going to be running here. Let's go and take a look. We can do localhost 4000 and we will see that this is our site. Now, cool thing is that we've also set up Nginx to serve or to uh, to where is if we take a look at the Docker file that we're using, we're copying this configuration here, right? So let's go and take a look at it. And this configuration, it's different from the one that we looked at before. And this is because now we added all of these different things. Now, we don't have to dwell too much into what each one of these lines is, but this is a very good way to do a what's you call a reverse proxy. So what's going to happen is that um, the user is going to send a request onto Nginx, and then with this configuration, we're telling Nginx to pass that request onto this other URL. Now this URL is going to be resolvable by this service because on our Docker Compose we have told it that there's another container which has a link to, and its name it's blog, right? So here, when we say like, okay, you need to reroute these requests onto block colon 4000, it's going to be resolvable by it. And then here we're just passing the correct headers that we need to pass whenever we're doing this type of redirects or reverse proxies. You can grab it for any other type of exercises. So let's take a look at it. Now, this is probably not going to work, and I'm going to tell you why. Uh, oh, oh, it didn't work. That's cool. Well, what I was thinking about, yeah, here is that it's always a good idea to build this. So for instance, here we're gonna name it, we're gonna try it different just so we can build it. And let's close this. Uh, it's always also a good idea to, whenever you shut down these things, to do Docker Compose now. That way, Docker Compose will remove these different containers. Uh, so the way to build something with Docker Compose also is very easy that way, because we've already specified all the different details that Docker needs to build something. So then we can use Docker Compose build and then the name of the service that we want to build. And then and everything kind of, I mean, is already configured there. So that's pretty neat. At the end of it, we end up with this image, which is class Nginx v1.3. And then we can do Docker Compose up again, and everything is gonna be working pretty much in the same way. But there's this difference that if we do, if we check all the different containers that we're running with Docker PS, we can see that there's two containers running. One, and Docker can tell us like the image that it's running, that it's using each container. So here we can see that we're using the newly created image. Now, here's another interesting thing that's happening. Because as you can see, we're talking about how Jekyll needs to install different gems and different things, different dependencies that it needs for the static site. Well, it already had done it before here, but it's doing it once again. And the reason why, it's because we removed the containers by doing, oh, sorry, not here, by doing Docker Compose that. So all of this, it needs to be done again because it's pretty much as coming into a new environment. Now, that's not totally necessary because, for instance, if we stop this and then we do Docker Compose up again, we can see that now Docker Compose is not recreating the containers. You see, it only says starting. Here, it was saying creating network and creating these different containers. So the only reason why we needed to do that is because we delete those containers. Now, I do recommend to always delete your containers because that way, everything that you build in a container and the way that you develop all of these different services are going to be well, they're going to be just more reliable and more robust. And also because you really don't need to have just that many containers there. Uh, we can check all the different containers that we have. We do docker ps-a, which is we've seen this before. And for instance, here we can see that these containers are still there. And it even says right here, status up. So for instance, if we do docker compose kill just to stop them, but not to delete them, and we take a look at it there, we see that all these different containers that we have here, they're not running. They're just there. Now, there is, still a container, although it's very lightweight, uh, it still has a size. So for instance, if we do docker ps-sa, a as in all and s for size, we can see what's actually the size of each one of these containers. So the virtual size of the container is going to be the size that an image is going to have. So they're always going to have that. And this container just like this is the size of the image, and this is the actual size of the container when it's running, which is 2 bytes. And for instance, Jekyll is 45 megabytes. So if you start just having a lot of different dangling containers there, then you can eat off your your storage. So, all right, let's now, I'm gonna start these things. Let's now move on to section 1.4. Before moving into or diving a little bit into what we can do with Django, wait, let me see if there's any questions. Everything's okay, cool. All right. Okay, so before diving into that, let me go back to section 1.3 just to show you. And here, this is everything we have here. Like we were using this Docker file and we were using this Docker Compose file, the same as this Nginx configuration, and this is our Jacob log, right? Well, the only thing is that this start getting a little bit messy. One thing that I always like to do is to organize my project in a different way. And usually this is the way that I do it. Basically, you have your top directory, which is going to be your project name. And then I usually create like a Docker folder, which will have different Docker files. It could be just one or multiple. I tend to keep it in just on one Docker file, but it's okay to also have multiple. Also, one or multiple Docker Compose files. Then there's another folder for any type of configuration, and then your actual application code. So if we move onto section 1.4, we can see here that things are a little bit different. Now we can only see like these different folders. Don't pay any attention to this vanilla folder yet. So then let's go into this, into what we have here in Docker. And what we have here in Docker, we have this Docker file and we have this Docker Compose file. Actually, this image folder, this blog folder is not necessary to have there. That's a mistake. But this is the only thing that we need. Now, the only thing is that if we move these files into a folder, then there's a few different things that we need to change. And let's take a look at our new Docker Compose file. So now, before we were just telling it to use the Docker file that was already in the same root directory. But here we're specifying what's going to be our Docker file. Now, it's interesting. It's a little bit tricky here because first we have to specify what's the context, and then the context is going to be relative to where the Docker Compose file is, because you don't know where that Docker Compose file is going to be in somebody else's computer, so it can't be an absolute path. It has to be. I mean, you can set it as an absolute path, but you might encounter different problems when other people in your team start using it. So first we set up this context, and basically what this context is, what this is saying is that whenever you run Docker Compose build, it's going to go one folder back, and it's going to use all of this as its context, which is what we were using before, and it's the root directory. And then from that root directory, we're telling it look for, look for the Docker file that you're gonna use to build this image here. Now this, we have to remember that this is only for building an image for this service. And again, we're telling them like what's going to be the name of the image. Let's use 1.4, just so we'll see that we're creating another one. Now here, I changed this from 8080, like this one. Oh, hold on, that was also from before. Well, now we're mapping like 80 to 80, so that way we don't have to do like localhost 8080 or anything like that. just localhost like that. This is also another good idea or another reason why to use something like an HTTP server in front of something like Jekyll or Django. So they were mounting this volume, and then this volume path is also a little bit different. And this is because this has to be relative to where the Docker Compose file is. So if we go back first, while we're setting up here, these paths are going to be, the context is going to be relative to where the Docker Compose file is, but the Docker file is relative to the context. So I know it gets a little bit tricky, but once you start using it, it gets simpler, or just it's easier to understand. Then the volume, it's always going to be relative to where the Docker Compose file is. So here we have to go one folder back, which is going onto the root folder, and then grabbing the images folder and then putting it there. Everything is also the same, like for these blocks, for these volumes, for the block volumes. So we have moved this here, but basically the output is going to be the same thing. Do this. We can do Docker Compose up, screen, Docker Compose up, and it's going. Oh, sorry, this is another thing. That now, if we're running Docker Compose here, we have to specify where the Docker Compose file is. And we do it by using this -f and then the path where the Docker Compose file is. Now I know that this might start getting a little bit confusing, but service not found for network. Okay, so we build our image, but now we're having an issue. And usually what I tend to do whenever something like this happens is that it's telling us that we can start a service block because there was an error that it wasn't found. So you remember how when we're using links to let containers know about each other? Well, that's because Docker creates like a local network as we were talking about. So usually a good idea is to use Docker Compose down. So that way we get Docker Compose to remove everything that it was creating. And then hopefully that's going to, yes, that's going to work. And I believe that's because we moved from one place to one, like we moved the Docker Compose file and I forgot to remove the containers from the other one. So now it's gonna recreate everything. As we can see here, is telling us like creating network Docker defaults, and then creating the containers, and then Jackie's container is gonna do this. But then the output is going to be pretty much the same thing. So now it's just Nginx telling us an error code. That's because Jekyll wasn't there before. Now if we do this again, then we can see that we're serving Jekyll, but our request is actually going through Nginx and then into Jekyll. All right, let's see how we're doing here. New subscriber, how's it going? All right, we lost something. Okay, so that's a way to organize your project. Now let's move on to onto setting up Django. Now there's different things that I like to do whenever we're setting up a Django application. Now we are not going to go a lot into actually like writing views or using the ORM or anything like that. It's just mainly about the setup of a project. And the three main things that I like to focus on the first setup of any project on a Django project is first logging. Logging is very, very important because that way we can see what an application is actually doing. So if we go uh, into sorry, check out section 2. Let's see what we have here now is that we have created, well, here, just to make things a little bit simpler, we're going to create a virtual environment. Let me get to the way I'm working on here. And you can use, I mean, there's different tools really out there. Like you can use ppenv, pyenv, or you can just like virtual env wrapper. Just for the sake of simplicity, there's really, I mean, I've used now a lot of those different tools, and it depends on the project that you work on. It depends on the team, and it depends on your workflow, which one actually fits better to you. So just for the sake of simplicity, I'm going to use virtual env wrapper to create a virtual environment for my local machine. Well, I've already done this, which is now here on M. So let's, the, the way to start it actually, I mean, if you want to create one, we're using Python 3 here. Basically, let me see. Let's take a look at the help. It's always good. Yeah, we can specify the executable and then where the environment is going to live. So for instance, we can just do it on M. And then our virtual environment is going to get created. Now I'm going to use the other one that I've created before, and the way to activate it is to do source, then where your environment was created, and then activate. Okay. Um, now, now that now that we have done this, we also now have these requirements. This one is just like very simple, very basic, and just a few things that we need to start off. As we can see, using we're using latest Django, the latest Django stable. So the first thing that you need to do is to do pip install -r requirements to make sure that all of that is installed. As you can see now, everything is already installed here. Um, So now we're going to start a project. Just for simplicity again, we're going to name that vanilla here. It's already started for you, and it's called vanilla because it's just like a very vanilla project. So if we go into here, into the project, now another thing that I like to do is to uh, to transform the settings file into a settings folder like this. That way we can separate different type of settings and all that. And I usually start with this common.py. I mean, this is just really a personal thing. There's a lot of different opinions about how to manage settings in a Django environment. That's probably a topic for another class or for a few couple of books even. But let's just start with this. The interesting part is that when you create a project using like Django admin start project, you don't really get any logging here. You have to go in and actually specify all of these by hand. And I do think that it's a very important part of a project. It allows you to see what's going on there, and it's always better when you have like a good format and better logging. Now, this is a very good example on something that anybody can use just to start off on a project. I actually tend to just copy paste this on any new project and start building on top of it as needs come. So the first thing that we need to see here is that we need to specify this variable, right? This login variable, and this is a dictionary. There are different ways uh, to set up login in Python, but Django actually makes this very easy to to manage, since as long as you give it a dictionary, a valid login dictionary, it's going to set up all the login for you, right? We don't have to do anything like use the setup the setup functions that the login module already has. Now, the first thing to notice here is that we need to specify different formulas. I like to always use two, and in most examples actually out there, you can see these two, like which one is verbose and the other one is simple. Now, the only thing is that I tend to change it a little bit. The verbose one is the one that I usually use whenever it's local development, and I tend to add this tag in front of it. Also on the simple one, which I forgot here, so I'm gonna add it. This is just so it's easier to see where a specific log message comes from, because when we're running these different multiple services in Docker, all of that usually tends to get aggregated into standard output. So this way, if you're looking at it live or something like that, then you can easily just see where the message comes from. Now, the other thing that is very important is that if we use the name of the file to create the different loggers, which we're gonna see in a little bit, then we can use this type of format as in name, which is the name of the logger, and then the function name, and then the line number. This is going to give us the full complete dot notation name of where this message comes from, and we're gonna see it in a few minutes. Then we have these different filters, which I don't necessarily use always, but it's always a good thing to know that Django already gives us like these different filters, which is require debug true and require debug false. So that way, any type of loggers are actually going to work either when debug is true or debug is false. Then I tend to specify um, my handlers, right? Which these are the ones that are going to actually print the message or send the log message to wherever it needs to. Now, usually we see a lot of different samples about logging into files or sending emails when logging, all that. And I mean, I do recommend to not do that using Django, and then just keep it simple and send everything to standard output using the login stream handler. If you need to do anything a little bit more with logs, I would recommend to use something like maybe Logstash, Splunk, or Sentry, or I don't know how many other products are out there. Some of those are free, some of those are not. But it's better to separate those concerns because also whenever you send a log message, if something happens there, there might be an error which is going to be even harder to debug in your application. So this is just something else to not worry about. Okay, now let's jump into the actual logger. So a logger, it's this conjunction of handlers, filters, and formats. Because we see the handler is the one that actually defines which is going to be the level of the message that is going to accept, the class that is going to use in order to process that message, then the formatter, which we have defined before, and then if any filters that is going to use, which we have defined before. And then a logger, what the way that it works is that it uses the specific handlers, and then other things that we can specify, but we're not gonna go too much in depth into that. Uh, a very important thing to know here is that we can also specify a level on a logger, right? So what this means is that whenever you print a log message, the first thing that's going to happen is that it's going to check the level of that log message with a specific logger. Which is, for instance, if we print anything within our vanilla project, it's going to check it against this. So because the level is debug, everything is gonna go through it. Now after that, what it does is that it sends it to the handler, and then the handler can further say like, okay, well, like for instance, this console handler, it's only going to handle anything that's info or above. This console debug, it's only gonna it's gonna handle everything else, right? Um, and then after that, if we were to have, we can also have children loggers, which, for instance, in this example, it could be like vanilla, and then let's say, I don't know, like API. So this is going to work for anything that we have on our API module. And we can put something like maybe the same thing, console. Well, let's say that we only want to use that one handler, and then the level of it we can bump it up to info. So whenever we print a message that's, let's say that it's a debug message, and we're in our API module, um, it's gonna go through. It's gonna go directly to this logger. Now this logger is gonna say like, well, this is a debug message, so it's actually going to throw it away, and it's not gonna do anything to it. And that's the main reason for this level option here. Now, if we send an info message, this logger is going to process it, and this logger is going to process it too, because this vanilla API, it's a children of just vanilla. So after processing the message, it's going to send it up to its parents, unless we can do this, propagate equals false. And that way, only this logger is going to process the message, and it's not going to send it to the parent. So, I mean, this is just something that's worth noting. And sometimes it's useful, but again, as everything, it's better to keep it simple. So if you don't need to do like this weird or more advanced type of filtering, then that's okay. You know, not everybody uses it, and there's nothing wrong with it. Let me see if we have any questions or anything like that. No? Okay. All right, let's move on. So this is login. Now let's take a look at what we have here. And there's just a very small, let me see what change. I'm going to check out this file just so we don't have those changes there. Yeah. We have created this very small view. It's just an index view, and the only thing that we're returning here is just a very simple HTML string. That way, we don't have to go into like the different types of views or anything like that. And we just really want to focus on this logging part. So as we can see, we're using two messages. One is the debug message, and the other one is an info message. Now, if we do something like manage, we can run Django's web server, less than 0 there, and take a look at it. So this is what we have, right? It's working on that. Now let's take a look at the output. You see, now we have these two different ones. And as we were talking about, let me see. Here, the way that we're getting the logger, it's by using the name of the file. So the name of the file is going to be printed. If we take a look at our format, it's going to be printed. First, we're going to have the level name, and we can see debug and info. Then we're going to have the ASC time. I don't know how to pronounce that, but let's call it like that, which is basically timestamp here. And then we're going to see the module name, which is views. And then we are constructing this name and function name and line number, which is basically like vanilla views.index and then the line number where we're actually printing that. And I find that this format is very, very useful for debugging stuff. So feel free to use it if you want it. If not, that's okay too. Now, the other thing, the other interesting thing that's going on here is that then we're also, as we can see this info message, it's also getting printed in the same format. Although we have this other handler which handles info messages, but it's using the simple format. So how come this is happening? And this is happening before we have this filter. So this handler is not actually coming into place because debug is equals true. So this handler is only gonna come into place when debug is false. That's why both of those have the same problem. And that's okay because we are in our local environments. Okay, now after, sorry, wasn't it? Yeah. After doing that whole login thing, let's move into testing. Now, really, I mean, we're not also going to go into the whole thing about writing tests, but it's just something that's very important to set up, which is how to run these different tests. So, for instance, here uh, we have created. Let me, let me have it here. Have created this very simple test, and the only thing that it's doing is just like observing this, what this value is true. Is something very simple. So now the way to run tests is to do manage test, and then it is running these different tests. Now there's it's actually a really good recommendation to usually use a different setting just for testing. So here in since our settings are very standard, we're not actually using a different setting for testing. But it's also good to use to create here another like coach test P1 or something like that. And that way, things like these, like for instance, database here we're using SQLites, but in whenever you're running unit tests, really you don't want to do that. I mean, still Django takes care of that. But for instance, if you have any other type of configuration here that's using like a remote API or something like that, you will want to not use your actual key, something like that. That way, you're really sure that you're not accessing anything, in any third-party APIs. And that's just an example of why to have a different test setting for it. Okay, so we have set up login testing. It's as we've seen, it's already kind of there with Django. And then the other thing to note here is how to debug something. Now, this is just outside our container, so let's go through it real quick. And there's different ways to debug an application, a Python application. Personally, I do love to use PDB. Well, actually, IPDB. And the way to use it, the best way right now is to do this. We have to run an application using IPDB, right? And what we run in a Django application, it's actually run server. So we can do Python -m IPDB to use it as a module, and then oh wait, let me go back. Yeah, Python -m IPDB, then manage.py, which is right there, and then run server 0008000. And right there, what we're doing is that we're running run server using IPDB. So from here on, we are going to use IPDB. Now, here you can see that we're starting everything. In order to keep on going, we have to hit C for continue and then enter, and then everything goes there, right? Let me see. Everything is running here. I'm refreshing this. Everything is running. We can see because of the line. Now let's get out of here. You have to close it multiple times IPv because whenever you actually hit Control C, it raises an exception, and then IPDB automatically restarts whenever it catches an exception. So now there's different ways to set breakpoints, and probably using something like PyCharm or something like that. It's easier because it's a more visual environment. But the only thing is that if it comes to a point that you don't have any access to PyCharm or anything like that, I think it's also a good idea to know how to do it manually. So there's basically two ways, and usually the way that you'll see it, which is the simpler way, or yeah, I mean you can call it the simpler way. It's to do this. Here you can do IPDB and then IPDB.setTrace. Now you will usually see it like this in one line, and this colon is just so Python interpreter knows that this is like a breakpoint. Now this is a simple way to do it, and it will work. Because we just put the breakpoint there, hit continue here, and then here we can see that our request is just hanging there, and now we're dropped into this nice IPDB console. So now from here, we can see, like, for instance, list all the lines, or we can do a little bit more helping. We can click, hit N for next, as in going into the next line. Here, this small arrow is telling us where we are and where we can move, etc. Or we can just hit C for continue, and everything goes according to plan. Now, the only thing about this is that we are blurring our code, because once we have it here, we have to remember to remove it. This has happened to me before, sometimes in production, then you forget that you have it there, which kind of sucks. So another option to do it is that IPDB has a breakpoint command. So if you run IPDB from here, and then you hit the question mark, you can see that it has this B and break commands. So the way that it works is like you can hit B and then the path of the file where you want it. So for instance, here is going to be vanilla and then views, and then we can take a look at it here. Sorry. Here we can see that this is the line 30, right? And this is line 40. So we can set the breakpoints by doing this. So it's going to be the path, which could be relative, and then views.py, and then colon, and the line number. Here is telling us breakpoint one at, and then the full path of the file, and then the line number. Now, that's how it works, but here, this breakpoint is actually not going to work. Wait, sorry, continue. We have to hit continue after setting our breakpoints. And then as we can see, we're not hitting the breakpoint. It's going into the view, but we're not hitting the breakpoints. And the reason why it's because of how Django's phone server works, and it is multi-threaded. So what happens there is that IPDB kind of gets a little bit confused about which thread is supposed to fall into these breakpoints. So in order to simplify it, we disable this, which is no using -- no thread. Let me take a look at the help. Make sure that and it's no threading, and also no reload. If we do this, then vanilla views 13, continue. Now we can see that we are falling into the breakpoint that we set. It's a little bit, I mean, it's not the same as having like that multi-threaded Django run server, but since usually when you do this type of debugging is it's just because you're focusing on one thing. I do find it that it's very easy to work with, and that way you make sure that you're not adding something onto the code that you don't really need there, and that way you don't make the mistake to send that onto production. Okay, let's see if there's anybody who has a question. I think everything is okay. All right. Okay. Now we've gone on to like the different things, different things to set up on a Django um, project. This is just so it's easier for us to develop. Now let's move into how can we actually set up this entire thing. We were talking about with Jenkins that we have like our like Nginx and our application server. So in this case, it's basically going to be the same thing, right? The only difference is that instead of using like, I mean, Jenkins, sorry, it was Jekyll. Instead of using like Jekyll server, we're going to use Django's run server. So this is basically how the requests go from the client and they go to the HTTP server, which then goes onto Django if needed. And then Django might call different services, for instance, third-party APIs or maybe a database or something like that. So uh, let me wait. Yeah, let me see. Oh, sorry. Yeah. So this is basically, I mean, how the entire application is set up. Now, usually in this application server, when we're doing this locally, we're using uh, Django's run server, and that's because well, it's meant to be like that for a development environment. But when we go into production, this is not the same. The thing actually that changes here is this application service. Sorry about that. Yeah, it's this application service, and the reason why it's I mean uh, the way that it changes is that we use something which is we usually in Python like a whiskey server. For instance, we can use uWhiskey or maybe Unicorn, or there's a couple of other ones which I honestly only use. I have only used uWhiskey and Unicorn, and I like uWhiskey a little bit better. There's really, I mean, there's really not one better than the other. It's just personal experience, or maybe whichever you're more comfortable with. The code well, the repository that I have there actually uses uWhiskey, but it's okay also if you guys want to use. I mean, if anybody wants to use Unicorn too. And the main reason here, which is something that I've seen that maybe it's not always clear because everybody always says, well, in order to go into production, you need to have like an HTTP server, then you have uWhiskey or Unicorn, and then you have your database or whatever. But nobody really talks about why do you need uWhiskey or Unicorn? How come run server is not? I mean, right now, like the latest run server is multi-threaded and all that. So how come we don't just use that in production? And basically, it comes to that. It comes on to the different threads that are used because these whiskey applications like uWhiskey and Unicorn, I mean, servers. What they do is that they help you out on to manage these different threads for requests, concurrent requests, on all that, and with different type of interpreters or maybe just one interpreter. So the simplest way to take a look at it is that your HTTP server should always handle everything that has to do with SSL and security to, well, yeah, like securing that connection and also serving static files. Because for instance, Nginx, it's very good at serving static files. You can also use Apache or maybe what other ones are out? Well, there's a lot of HTTP servers out there, but most of them they're very good at serving static files. So that way, that's what that layer handles. And then you have your WSGI application, which what handles is a way to handle concurrent requests. But each one of the requests is it's actually a thread or a process, which in this case will be running a Django instance. So at the end of it, then you have your Django application, which is the one that you're developing, which might talk to like the database or something like that. So by having that abstraction layer from a WSGI server, we don't really have to worry about writing things that are multi-threaded or not, or worry about anything like that. And those type of servers are actually going to help us with that. Well, hopefully that was clear. Let's move on to this is how well this image here is mainly like the idea of it as we were talking about, and then how can we translate this into Docker, right? And basically we have the same thing. The only difference is that all these services are going to run in containers, which I just really want to mention that not because they're running containers, that means that they're microservices. That's a totally different architecture, or well, not totally different, but it's just a different architecture. And what we're doing here is that we're still running maybe in the same host, or you could maybe running multiple ones, but let's talk about like running in the same one. These different, like your HTTP server, your application server, and your services will be running in containers, but each one of these containers are actually based off of different images. So we can see here in this other square. So for instance, our HTTP server is going to be based on the Nginx image. Our application server is going to be based on a Python image, and our database service is going to be based on a Postgres image. So let's jump into how can we do that, right? Let's go into section 3. Yeah. Remove this block, which we don't need. All right. Now let's take a look at what we have here. Basically, there's a few different things that are going to change here, and we're going to start with our Docker compose. So first, one of the things that we change here are the links. So now Nginx is going to know about our Django service because we moved from our static site into Django, right? And then we are going to define our database service. Here, again, the way that we name it, or the way that I name it, it's, wait, it's just the name of whatever services we're going to run. We're using the latest Postgres image, so that way we don't really have to do anything. And then here, this is a very important part of it, which is these volumes. So before we were talking about how can we mount any type of files or directories from our host machine onto a container, which is like, for instance, here. We have our default configuration, which is a file that we can access from outside a container here. Sorry, default. This is the one that we're mounting there. But then this is a little bit different because here, what we're doing actually is that we're creating a what you call a named volume. And the name of it is Postgres data. We're defining it here at the very end of it. This is another key and another key of the Docker Compose file. And the way to define it is the very simplest way is to tell it just what's going to be the name of the volume. Now there's different options that we can use in these name volumes, but I don't know, probably like 80% of the time, the only thing that you need is just to specify the name. Because you can also specify like what's going to be the driver that you're going to use and all that. But in order to keep it simple, let's just use the name of our volume. Now, once you create that name volume, you can use it to mount it to any type of container. So think about a name volume. Yeah, it's mainly it's kind of like a folder that Docker is going to manage for you. So you don't have to worry about permissions. You don't have to worry about where is it and all that. It is somewhere in your computer, and well, it's actually somewhere inside the Docker machine or the Docker VM, uh, or the Docker kind of like context. So this is you can take a look at it, or you can think about it as if it were a folder, and then we're going to mount it here, which is what Postgres uses to save its data. Now we're doing this because that way we can delete our Postgres container, but whatever data we have put into the database is not going to get deleted; it's going to persist. So that's basically one of the main usage of name volumes, which is persist data. So whenever you have a database or something that needs to persist some data and you wanted to, uh, you need to use a name volume. You could also just mount a folder that's in your computer, and it doesn't have to be a name volume, but I have found that there's always permissions issues with that. So it's easier to just use a name volume for these kind of things. Then we're going to open Postgres port, and there's really no reason to do that. If you don't want to, that's okay. I tend to always do it just so I have another way to access the database in case there's anything else that I need to do, any type of debugging or something like that. Then we're setting up these different environments. Now, this is something that the Postgres image already works with it. So for instance, we can take a look at it if we go into Docker Postgres image. There's always a nice documentation for all of these different images, and it tells us uh, environment variables. It tells us which environment variables is going to accept. We're going to set the Postgres password, which is going to be Postgres user, Postgres database, and where is going to be the PG data. Um, this is an easy way that most of the images that you can pull from Docker Hub are actually going to have, and it's an easy way to configure, which is awesome because that way we don't have to do anything other than just specify it on our in our Docker Compose. Then we're going to build our service. This is the one that's going to be custom for us. So we first set our context, which is our root directory for the project. Then we tell it where the Docker file is going to be, and we're going to mount our code into SRV triple dot vanilla. And then we're going to tell it that there's another container called Postgres. So as you can see, these links, Nginx, we go back to here, Nginx, which is the SSB server, only needs to know about Django, which is what's happening here. And then Django only needs to know about Postgres, which is what's happening here. And that's all the links that we actually need in order to make this work. So let me do something. Um, okay, there's something actually that's missing here, which is the name of this. Let's call it. I mean, it's always good to specify a name. You don't really have to, Docker is going to create a name for you, but it's easier for debugging or whenever you want to delete some images or something like that. It's easier to specify here. Let's do like Django version 1. And then we're going to do Docker Compose, specify the compose file, and then do up. It's going to build the image and everything else. So as we can see, well, we didn't go through the Docker compose, I mean Docker file, but we can go through it here. There is only 7 steps, and this one is a little bit different. But we can see what we're doing is that we're starting this image from another image, which is called Python 3.7. And then we copy the requirements file onto a temporary folder, and then we run pip install requirements. Now, there's different examples there as to, and some of them copy the requirements file into the container first, some of them they don't. I tend to do it because that way, as we were talking about, like these different layers are cached, right? And this way, it's easier actually. It becomes faster to set up all these different things if we copy first the requirements.txt over here. And then one thing that I always like to do whenever I'm working on a Django project, it's doing these, creating an actual user that we're gonna use to run the actual application. Then here what we're doing is that we're creating the folder where our code is going to live inside the container, and we're setting correct permissions to it. And then by using this user portal, what we're doing is that we're telling Docker um, that everything after that is going to be done by that user. So here. And this is something that is really recommended because that way, whenever a container is going to run, it's actually going to run as this portal, like whatever runs inside that container. If you do not do that, what's going to happen is that everything that runs inside the container is going to run as root. And we don't always want that because that might be a security breach. Then we set up the work here, which is whenever you drop into that container, what's going to be your base directory. Um, Now, we've just built this image, and then Docker Compose is creating these different things. I mean, these different containers. We're creating Nginx and attaching this to here. Yeah. Now, as we can see, there is an error actually here. We have Docker Django 1 exited with code 0. We can't see what's going on there, but a way to figure it out is that we can also just fire up specific services. We don't have to fire everything up that's defined in Docker Compose. So we can do Docker Compose up Django, or we can even just run it. Actually, there's a better way to do it. Like run Django, and then let's just do big bash. That way, what we're doing is that we're basically creating that container, running it. We can see by doing Docker PS, we're running this container using the image that we just created, and it's called Docker Django Run, and we're dropping into that container. So for instance, if we do who am I and portal, use the user that we define, and then where am I? It's in SRV triple dot vanilla, which is the work that we defined before. Okay, now what we're gonna do here is that our Docker Compose file says that, oh, okay, I know why. Okay, so everything is set up here, and as we can see, it is exited as code 0 because our image is not defining a command that we're gonna use. Now, we can actually um, fix that by doing this. Finding here manage.py from server, and then this is going to help afterwards. So I'm gonna use 8080 here. So every time that somebody creates a container out of this image and runs that container, this command is going to get executed. We can see it if we do this. First, let me do Docker Compose down and remove all these different things. Yeah, and then let me rebuild this Django image. And let me take a look at this thing. All right, everything's okay. Okay, we just built the image. Now it has that command. We can see it here, the last step. So now let's go and fire this up. Okay, now we can see what are we running, and we have here Nginx, Django, and Postgres. Now, the only thing is that if we take a look at our Docker compose file, we don't have in this service, we don't have anything specified as in like which ports are going to be mapped or anything like that. And I will tell you why. But first, let's just make sure that this is running correctly, like this manage.py. And the way to see it is that we need to drop into that running container. And we can do that again with Docker Compose by specifying which is the Docker Compose file that we're going to use. Um, then do exec. We can just do bbash. This is going to, let's get it. Sorry, I forgot the name of the service. Now here we can do ps out, which now we're inside this, and we can see that we are actually running running the server. So we can do, for instance, curl localhost 80, and then we get that image. Actually, if we go here, we're gonna see also our debug messages. But the only thing is that this is not mapped out to the outside world. So even if we do like localhost 8080, we're not gonna reach it. So we need to fix it. Now here comes another type of setup too, which is something that's actually very recommended. Let me remove it. It's recommended a lot to manage the different environments that we're going to use. And here we have, for instance, in Docker, in this Docker folder, now we're going to see that we have Docker Compose, our regular Docker Compose, then we have Docker Compose Dev and Docker Compose Prod. So if we take a look at those, we can see that we can go to first, this is our regular uh, Docker Compose. Now we can take a look at Docker Compose there. Here, the only thing that we're actually specifying are the ports that are going to be open, and the image name that we're going to be using, and a lot of other configurations that we're going to need just for development. This TTY and STD in open, what's going to help us with is going to be with debugging. Well, we're going to take a look at that a little bit after. So as we can see, this is one of the good things about Docker Compose, because we can have our base Docker Compose, the one that we have here on the left, and on the right, and then we can just override a few of these different options on these different Docker Compose defining Docker Compose files, defining these different environments. So for instance, for our dev environment, we're going to open the 8000 port, and we're going to run managed run server and run it on the port 8000, and we're even specifying an image name. And this is going to override, this image is going to override this other one here, and then everything else is going to be using the same things. So the way to use it is to use Docker Compose F, Docker Compose first, our base one, and then Docker Compose.dev. So let me Docker Compose Docker YAML, and then also again dash n Docker compose there, and then we do up. So here now we're seeing that it's running Django, the Django run server on 8,000. And now everything's working. And that way we have a different configuration just for our local development. And we can take a look at it. We can see it if we go and we take a look at our prod Docker Compose. Now this one is a little bit different. As you can see, we're also specifying another image. Well, right now it's the same one, but we can specify another one if we want. We're specifying a login driver. Wait, yeah. We're also specifying, we're mounting this whiskey file, and instead of running run server, we're using new whiskey. We are also mounting another configuration onto Nginx. So let's take a look at those things. Everything is under configuration. So first, our Nginx configuration is going to change a little bit. And instead of having all those different proxy passes, I don't know if you remember, but let's take a look at the other one. So here for the base location, what we have is all of these different like proxy, read, proxy pass, set header, and all that. So for Whiskey, it's very simple to define. The way that we do it is kind of like include this etc. etc nginx uwhiskey params, which is a file that nginx comes with, and then we specify this uwhiskey pass onto Django 8000. And again, Django 8000 is going to be resolvable by nginx because of our Docker Compose file, the base one, since it has this link onto Django. Now let's also take a look at our USD configuration, and this is something that's very basic. You can also grab it in order to experiment or for other projects. And first, we're moving into we're changing directories into our code is, and then we are telling it where is the application. Now, the good thing is that whenever you create a Django project, Django already creates this service, this file for you, which we can take a look at is here. It's very simple, and it's by default it's going to be there. So it's always going to be like the name of your project and then .whiskey and then colon application, which is basically this variable that we have here. Then master true, because in this case we're only running this uwhiskey service, and then this is really good also to make whiskey a little bit more performant. This is how many processes whiskey is going to run. This is the buffer size of each one of the requests. This is the harakiri value, which is how many seconds is it going to, well, after how many seconds is whiskey going to kill a process that's been idle. Also, this is how many requests concurrently this is going to handle. Now, this is very important, the user ID, and this is the user ID as to how uwhiskey is going to run as, right? Now, we have to remember that it needs to be the same that we have used for when we were setting up our image. This for because also all of our code, the permissions in our code are going to be for that same user. So it could be, I like the user, the name portal, because really, even if it's an application, it's kind of becomes a portal. Then this is going to be the socket that Whiskey does. It could be different types, different type of sockets. It could be a Unix socket too, if you want. But this is easier to to set up in the way that we're doing it, as in UWSG passes it to another container. Um, then we're enabling threads, and then we are telling UWSG to only use a single interpreter. And this is because it's going to run multiple processes, but it's going to use the same interpreter. But I think by default, this is actually false, which is for each one of the processes that you run, there's going to be a different interpreter for each one, a different Python interpreter. And what that means is that, for instance, let's say that you have a cache setup, which is a memory cache. So then one process is not going to see the same memory as another process if this were to be false, right? This way, all of these different processes are going to be true. I mean, are going to see the same things in memory, and they're going to use the same interpreter. They're going to also use the same like caches that Python uses and all that. Now, it depends on the type of application that you're developing if you want it to be true or false. But I usually start with true and then see if I need to move it into uh, into false. These last two here are also to make WSGI a little bit more efficient. Okay, so that's more or less our configuration for our production environment, which we can again run it here if we wanted to. And let's take a look at so Docker compose YAML, then also Docker compose prod. Oh, uh, well, this is oh wait. Ah, wait. I haven't configured this driver locally correctly. So let's not use it. And as we can see now, WSGI is actually running all these different processes. These are the 10 processes that we ask it to run. You see it says right here 1, 2, 4, 6, 7, 8, 9, 10. Postgres is also running, and I've already run like the migrations and all of that, but you can we can easily do it by doing Docker compose, and also again Docker compose prod, and then run manage.py migrate, for instance. Oops. Uh, manage.py. Okay, let me see where am I. Oh, no, sorry. I forgot to put the name of the service. I always forget to. So this is an easy way to run migrations, or any other type of thing that you want to run locally. So now if we go here, it's not going to work because we're not running run server anymore. We're running UWSGI, so we're not accessing that directly. But if we go into localhost, now we're going on to Nginx, then through UWSGI, and then to our code. So now everything is working, and this is basically the same way that we will be running it in production. The only difference is really like it's running in our local machine. So that is really neat. Okay, so these were like kind of the different ways to set up different environments and all that. Now, there's a few things to note here. Like for instance, when we're talking about logging, this way, whenever we're running these different things or all of these different services with Docker, that's why we want to send everything onto to standard output, because Docker is always going to spit out anything that runs inside a container and that brings something into standard output. So that way we have all of our different logs here. Now, usually what I will do is to send it to syslog or rsyslog, and then from there send it to any other type of log processing package. So we can see, like for instance, here at the very end of it, we see our log messages. Um, so that's a very easy way to set it up, and that way it's simpler, and you don't have to worry about anything going wrong whenever you're printing log messages. Now, the other thing is, how can we debug it? So we saw how were we debugging our Django application just by using like a virtual environment, and from then doing it outside a Docker container, which is always a good idea because sometimes you want to debug something and not put like not having Docker to be a factor onto whatever is going on there. Wait, let me just check real quick if anybody has any questions about that. All right. Um, so that's always a good first step whenever you're debugging something, just to do it using a virtual environment and then just running Django with nothing else, right? But then sometimes you need to debug something with everything else. All of the rest of the service is actually working. So one of the ways to do it is by um, wait, by doing this. This is why these two values are important, because that way we're telling Docker to open the terminal, to open the terminal and to open the std in, which is whenever we type in something into the keyboard for this container specifically. So there is another Docker compose file here, which is called ipdb. And this one has actually everything that we need. As we can see, it's running like Python, -m, IPDB, run server, and all that. Another thing to notice here, and also the no reloading and no threading that we were talking about before, because of run server's multi-threading nature. Now, the other thing to notice here is the format that we're setting up this command. And it's always good to have it in this format, in an array format, which, well, I think it's actually called JSON format, but it's an array. Um, and that's because that way, whenever you run this container, what's going to happen is that this process get is going to get PID one in that container. That means that whenever you close down a container, that container is going to send a terminal signal, which is a SIG term, onto whatever is running inside itself, right? And if we do it this way, if we set it up in an array format or in a JSON format, then that signal is gonna get routed onto this process correctly. If we don't do it like that, if we do it like and just actually give it a very long string, then we might have some luck, and it might also, the SIG term might also be routed onto the process, but that's not necessarily going to happen, and it depends on a lot of different things. But this is a very easy way, or a way to make sure that we're doing the correct thing. So let's see what we can do with this. We can now run docker compose docker.yaml, and then let's set up our IPDB and then fire everything up. Now here we can see that it just stopped because it's running IPDB, right? But then the thing is that here I can't actually give it any type of anything, right? I mean, there's just this is just like doing a table on a bunch of different log files. Or well, it's not log file, but yeah, just so we're just looking at the outputs of it. We can't give it anything. So the way that we do it, that's why we open the std in and the tty, and it's by doing docker by attaching onto that container. Docker compose f, docker compose YAML, then the IPv2, and then attach, and then service YAML. Oops, sorry. Oh, Yeah, I forgot. Attach is actually just used by Docker itself, not recompose. So we can do Docker attach and then the name of the service. But there is something to note here that when you Docker attach, there's this thing called seek proxy. So if you want to drop out of that attachment, you do Control C, and then that Control C it's actually going to send a seek term again to the container. So we don't want to do that because we're only debugging. We might just want to debug and then drop out of it and all that. So and then have that service still run. So what I want to do here is specify seek proxy false and then the name of the container. And here we are. Now we're dropping into this IPv uh, uh, terminal. So here we can do vanilla, fuse 13 again, and then continue. Everything is gonna run the way that it's supposed to, and then we do this, and now we are debugging it live. Pretty cool, right? Well, I think it's really cool. We can do like next, next, and then just continue, and everything is gonna continue the same way. Now, if we hit Control C, oh yeah, so it's also uh, gonna drop out because we just killed IPv. But this is an easy way to debug anything that's happening inside a container with everything else also running like the other services and all that. There are different ways to do it also with PyCharm with like remote debugging and stuff like that. Um, but again, this is just something that it's easier to do without any type of like extra packages. But if you like visual debugging better, then PyCharm is really good. Uh, VS Code is also really good. I tend to just do one thing on one screen, and sometimes those IDs are a little bit too much, but they are really helpful too. Um, Only for just to finish this, there's one more thing that I wanna go through. I mean, yeah, one more thing, which is the whole thing that we were talking about, executing executing processes and having them having them close in the correct way. Remember when we were talking about using using like this array this array format or not. So there's different ways to do this, and usually um, you will see something like this, like just entry point.sh. So instead of having your entire command here, you can actually create a bash script which is going to have the command that you need. So for instance, we could actually have something here which is just like entry point.sh, and then have here something like this in bash. Basically that. But now the only thing is that if we do this, what's going to happen is that when the container starts, it's going to run this bash script, and then this process is going to get run in a sub shell. So if we don't want to do that, or else whenever you close the container, this process is not going to it's not going to exit gracefully. Now, really, most of the time there's no harm done. The only thing is that you're going to have to wait a little bit more for the process to be killed abruptly. But it's always good to try and do things the correct way. And the way to do it, if you're using a bash script, is to use exec, and then this is going to be that one thing. I mean that process is gonna get is gonna get routed the correct signals the way that it needs to. Now, this is I believe that this is one of the reasons why usually people say that there should be For one container, there should be one process running on it. But sometimes this is just kind of a hassle because, for instance, on your local development nowadays, you might have like Django running as you will like something like Webpack or maybe Browserify or something like that running at the same time, watching over your JavaScript files and then processing them whenever some of those changes. Now, if we do this, if we do something, if we try to fire up two different processes here, then they're not gonna get those signals routed in the correct way. Now, the best way to do it, actually, I mean, there's different things that you can use, but um, I do recommend using dumping it. It's very easy to install. It's very lightweight, and really, there's even there's even a an example here. So, for instance, if you wanted to run Django and let's say like Webpack, uh, we'll do it this server, and then something like npm what's it like def or well, Webpack. Then I can remember all the parameters. It's something like oh I think it's just like Webpack watch. Um, so that way, Dominic is gonna take care of routing those signals in the correct way. Now, this is the way to run it, and then you will have to update the Docker file to install Dominic, which like this Python 3.7 image is based on Debian, so really you could do get apt get install Dominic. And that's pretty much it. That way, everything is gonna be running correctly. Um, I think that's pretty much it for all of this. Uh, we're on a little bit longer than I was expecting to. So, anybody has any questions? I'm gonna um, well, if anybody has some questions, you guys can still like use the chat. I'm gonna be there for a while, and also I'm and I'm so let me post where the slides are in case that you want to go through maybe the video and the slides too or something like that. There's also this is my email and this is my Twitter handle if you want to follow me. Um, this is also my blog where I tend to write about these kind of things. Um, and most of the topics that we went through here, I'm gonna post different articles just going a little bit more in depth. Um, I'm gonna also post where the slides are in the different chats. I mean, yeah, slides here. There you go. Slides. Okay, this was fun. Um, yeah, so just let me know if you guys have any other questions. And thank you for watching.